Okay, so the next task that we are going to do is we will create a logical tunnel. Nowadays we have VPNs, that is very famous, virtual private network. Assuming that this is my ISP and this is my office and this is my another office. This is how my ISP is connecting from me. I want to form a tunnel from here, my head office to my branch office. And I don't want any difficult stuff. I want a normal tunnel which can send my broadcast or multicast, whatever. So how do you do that? So what you can do is, for you to form a normal GRE tunnel, you have to say interface tunnel, any number to the tunnel. Give it an I'll do it in Notepad for the ease of things. I'll say enable configure terminal interface tunnel 1 IP address of the tunnel. Understand one thing, I will not advertise this tunnel IP into OSPF or RIP. Simply I will set IP address, I'll say 10.0.0.1. This is a class A subnetted to class E. Now if you are entering into a tunnel, you will enter from a source, so you will have a tunnel source. As of now, it will be my gigabit 0/0 interface. We are entering the tunnel from here. You can also put an IP address of this interface. I am putting the interface over here, name, and tunnel, if it starts, it should have a destination also, right? So tunnel destination, what I will do is, I will take the tunnel destination of this router's gigabit interface, so IP interface brief. This is 4.2. So I will say tunnel destination 192.168.4.2. Tunnel mode is generic routing encapsulation over IP, GRE IP.
Generally,
yeah, is the tunnel mode GRE IP, and no shut is required. Okay, done?
Yeah.
Okay, so what we will do here is we will copy the commands and we will paste commands.
Destination we cannot put interface, only IP, should be IP.
Sorry?
Destination.
So destination will be our IP address. Let us paste the config. Tunnel source, tunnel destination, mode up. Let us do the same configuration on router 4, but for router 5, he will have the IP address reverse. His tunnel source is 0/0, yeah, correct. Tunnel destination will be 1.1, isn't it? This interface, show IP interface brief. This is 1.1. So I am starting a tunnel from here now. I will end it over here. IP of this. I will say, okay, source IP is, source interface is this. Understand one thing, you must have connectivity from these IPs. If I say my destination is 1.1, I must be able to reach that interface, or else the tunnel will not come up. And I am not using this to advertise it to the ISP. What I will do is I will paste this configuration on router 5. Let us see now. Ping 10.0.0.1. Am I pinging 10.001? Yes, this is my show IP interface brief. This is my tunnel interface. My tunnel is also up. This is a very basic tunnel, GRE tunnel. So if I say trace route, how many hop counts are there? You can say 1, 2, 3, and this is the 4th hop count, right? If I say trace route 10.0.0.1, what does it feel? It is only one hop count away. Technically, if I ping 192.168.1.1, sorry, if I say trace route to it, how many hop counts am I going? 4 hop counts. Now this is your actual underlay network. This is the physical path that you are going, and this is your logical tunnel. So no matter how many hop counts you are traveling, this looks like one single hop count away. Okay, now what people will do is people will create one more tunnel inside this. They will use IPsec tunnel, and they will put encryption, they will put hashing on this tunnel, so that this tunnel has encryption, hashing, SHA, MD5 and all stuff inside. So you are sending data inside this tunnel. Also understand one thing. If I say I have a network like this, now sooner or later, I'll show you how to run IPv6, Internet Protocol version 6. What we can do here is, these people will run IPv6 over here. These people will run IPv6 over here, but your ISP will run IPv4 only. These people will run IPv4 only here. So if you want to migrate from IPv6 to IPv4, that can also be achieved using this type of tunnel. The only difference will be the IP address here will become your IPv6 address, and tunnel mode will be GRE, or we'll change the tunnel mode. Simple as that. This one will be your IPv6 network. This one will be your IPv6 network, and we will use this tunneling. 6 to 4, we will have a tunnel later on. So when the data comes in here, this is IPv6 data. This IPv6 data is sent out as IPv4 data. For this guy, for this router, he thinks it is an IPv4 packet. He simply puts it like an IPv4. This guy does a decapsulation. Again, IPv6 over here. Let us see one thing. If I say I take a packet over here and I push a packet over here, let me open the packet. Let me open the packet, and it will say, it will tell you all. See, the ping process starts. ICMP echo message sends. GRE uses IP protocol 47. See, encapsulated via GRE. If I can show you the Wireshark capture on the other software, it will tell you that it is. So for these routers, they don't come to know that they are forwarding the route of 10.0 network. They think that this data belongs to this interface. But internally, this is the tunnel's data. So this is our GRE tunnel, generic routing encapsulation tunnel.